Okay, if example 1 wasn't easy enough for you, let's look at example 2. Use a cofunction identity. Cofunction identities are the ones right above. That'd be like 20 through 31. Thank you. 20 through 31. 20 through 26. No, 20 through 25. The ones on the left.
Yeah.
Those are 90 minus theta.
Yeah.
And then the other ones are pi over 2 minus theta. In general, let's just take a look at any one of them. Let's say cosine of 90 minus theta. That equals sine of theta. If it's a secant of pi over 2 minus theta, that's the same as cosecant of theta. Just in general. All right, you got sine and cosine are cofunctions, secant, cosecant are cofunctions, tangent, cotangent are cofunctions. 90 degrees and pi over 2 radians are the same angle, right? So whether we're dealing with a 90-degree angle or a pi over 2 if we're in radians, if you do 90 minus theta, you get the cofunction of theta. Pi over 2 minus theta, you get the cofunction of theta. And every single one of those is going to be the cofunction. So take any trig function, let's say cotangent, and we have either a 90 or a pi over 2 minus theta here. That's going to be the same as the cofunction, which is tangent of theta over here. That's just how it works. All right. To give you a visual representation of what's going on here, let's say we have some right triangle here. That's probably pretty good. That's about a 20-degree angle-ish. All right. If that's 20 degrees, if I do 90 minus 20, how much do I get? 70 degrees. That's how big the other angle is. All right. So this 90 minus theta, if we're in a right triangle world, if 90 minus theta is one angle, theta is the other angle, you're looking at the two angles of a right triangle. The two acute angles of a right triangle, right? So if you consider this, like for the 20-degree angle here, this is the opposite, this is the adjacent, and this is the hypotenuse. All right? And I did the sine of 20 degrees. The sine of 20 degrees here would equal the opposite. Let's just call this W and call this X. Let's just give them names, all right? If I did the sine of 20 degrees, that would be W over X, right? All right. If we take a look at the 70-degree angle and identify opposite, adjacent, hypotenuse, now this is the opposite side for 70, this is the adjacent side for 70, and that's still the hypotenuse for 70, right? Looking at the cosine of 70 degrees, that's adjacent over hypotenuse, that's also W over X. These things are equivalent to each other. You don't have to go through this much trouble to do it every time. But if they want an equivalent expression for any trig function between 0 and 90 degrees, just do the cofunction and then give me the other acute angle measure. Do 90 minus theta. So in general, if you're trying to do an equivalent expression for any trig function, the way it goes is step 1, write the cofunction. Step 2, subtract from 90. The end. All right? And that's just how it works. But again, the reason why is because of that, the whole, if you jump over here, the opposite adjacent switch, and that just creates the cofunction situation. If it's tangent of 20, opposite over adjacent, cotangent of 70, adjacent over opposite. Right? If it's secant of 20, that's hypotenuse over adjacent. If it's secant of 70, or cosecant of 70, it's hypotenuse over opposite. So when you swap sides, the opposite adjacent switch, you're looking at the same angle. So in general, equivalent expression, write the cofunction, subtract that from 90, and you get your answer. That's what we're looking for there.